Yes. So today this is an important session, and we are going to learn how to run the WFlow model. So this is to check if you can run the model from your PC. So this is, I think, a very important session today. So the first thing, maybe we need to go first to the WFlow file I shared with you, and I can share it again if you lost it or misplaced it. I can share this one again, but let me first go to the folder for the WFlow. This is the training. This is the WFlow. So here, this is the master file to run the WFlow. So we are going to use this master file to run the WFlow. So this is the first thing. The file, it has an extension. It's called .toml, a toml file. And this is like an important file or the master file to run everything. So we are going to open together this file now. So this is the file. And the important thing we check, as you can see, this is the start file. This is the name of the file, wflow underscore SBM. And this is the starting of the simulation, 1st of April 2024. And the end time, originally it was like 30 of May. So we can make it 3rd of April. I change here because to make the simulation fast, and we check the result together. This is the time step. It is in second, 900. If we divide it by 15, if we divide it by 60, it will give us 15 seconds. So we can decide like the time step, the suitable time step. It can be every 15 minutes, it can be hourly, it can be like every 6 hours or every 2 hours. But in general, for flash floods, maybe the minimum it is like hourly. So don't go for a course time step. This is the original name. It was like this without test. But because I don't want to overwrite the existing file, then I write here test. Here, these are like different information about the input, where to find the input. Here, this is the path to save the output. We are going to check now, the output. This is the static maps we opened in the past, this static map. This is an important different files for running the model as an input. It has, for example, the river location, it has the subcatchment, it has the forcing, and the forcing here we talk about the temperature and precipitation. These we talked about them. These are like dynamic variables, and they should change. Also, we have this potential evapotranspiration, and if there are some gauges, we can also add the gauges, and also the path forcing. Here, these are like different input information. If there is snow, we can write true. If there is no snow, we can write false. And if we want to reinitiate, if there is a glaciary. So these are like different kind of information for the model. Also, the output file, we will find this name, output.nc. After running the model, we are going to see also like output.csv. We can open this file also together. and these are just different kind of information in this like master file to run the WFlow. So this is for example here the water holding capacity, the actual evaporation, the total storage. So these are different information which are important to run this file. So what we change here in this file, we change only the ending time step to check quickly. So we change this from May to April, and here from 30th of May to 3rd of April. And we change the name here not to overwrite the existing information. So this is our master file for WFlow. It is here. So we can go back. I'm going to share after this session the recording and also the training file. So the first thing we said here, we changed like the ending date or the end time for the simulation, and we change also the output file. So we said we added here like underscore test not to overwrite the existing file. Then after that we can go to our prompt here, and hopefully we already downloaded Anaconda, and here we can run Anaconda. It's a terminal for Anaconda. I opened just now Anaconda, and then after opening Anaconda here, it said we navigate to where we save this WFlow file. So this file, it is here. This is the path in my PC. Maybe the path it is different in your PC or in your laptop. I put it here in IGAD, HKV, training, WFlow. So this is the file which has this TOML file or TOML file with these different folders. This is the static map. We opened these static maps in the past by using Panoplay. So I need to go to the path here, navigate to the path, and I describe here how to navigate to the path. You can use CD double dot because I'm here in this system 32. I need to go up, CD double dot, and then again CD double dot, go up. Then when I write D, I move to folder D. Then when I write the command CD, I go to EGAD, then I go to HKV project, I go to training, WFlow. Maybe you save this file in a different path, so you need to follow the path in your laptop or in your PC. So I will do that now just to demonstrate. I'm also recording this. So CD space double dot, I go one step up, again CD space double dot, I went one step up, this is D double dot, and I move now to the folder of D, CD, EGAD, I can go again, CD, HKV project, CD, I think training, CD, WFlow. Yes, this is my folder. dir is just to list what is inside this file. So I went to the path where I saved this folder for the model. Then after that, we said we need to activate our environment by using a command conda activate hydroempty. We already created that environment in the past. We can check first if it is still there. Conda environment list. It will list for me all the environment that I have. This is the hydroempty. It is available. I have other environments. but this is the hydro MT. It is here. Now I can activate my environment. Conda activate hydro MT. Yes. Now this is activated, the hydro MT. You can see here. It is well activated. Now the next step, we need to check the executable file. We have an executable file. Normally it is available in programs file, Daltaris, WFlow, WFlow 8.1, WFlow underscore CLI, bin, and this is the executable file. So it is available here. If we go to C, program files, if we go to Daltaris, WFlow 8.1, WFlow CLI, bin, it is here. This is the executable file to run the model. We can copy this path. I copied the path, but also I can navigate if I want. So now I need to run the model and to check if the model is running well. This is maybe what you need to do. I will try to finish before 10. So as I said, the important thing, we need to tell the model that the executable file, it is available in this path. Now this is the path. I put these two invented commas here, and I need to add here the name for the executable file. So here the name is WFlow underscore CLI. WFlow underscore CLI.exe. So this is the executable file to run the model. Then I like pressed space to create a space here. Then I need to write the name or the master file name here, WFlow underscore SPM. So this is the file that we want to run. This is the master file to run here. As I said, first I put the path to this executable file. In general, it should be like the same path. I assume it should be the same, because when you install WFlow, it is installed in program files in Daltaris, and this is like the same path inside Daltaris. And this is the executable file, and this is the master WFlow file that we want to run. So I can try to run. I pressed enter, and I'm waiting for the model now to run. It should run hopefully for only 2 days, not 2 months, just to make a quick demonstration. I think it is going well. It is running. So the model is running now for 2 days, creating outputs, and here it show me like it was fast because it was only 2 days, but and here it tells me at the end the output file, they are in this folder in outstate.nc. So this is the path. So the model, it was successfully run, but only for 2 days. We selected 2 days because we want to just quickly check. So now we can check in our output folder. I can go to D, EGAD, HKV, training, WFlow. This is where I saved everything. So this is the original folder. And as you can see here, the result and the output, it is big. It is 158 megabyte. But for the folder that I just created now, it is smaller. It is here in training. It is in the same place in WFlow. This is the one that I just created now. As you can see, even the date here, today is the 4th of July 2025. I created this folder at 9:50 a.m. So this is just the folder I created now. I gave it a different name. I didn't give it same name like the previous one. If I gave it the same name, it will override the previous result. But I put underscore test to save this new result in this new folder. So the result, they are saved here. This is like the file. And as you can see here, the output, it is just 5 megabyte. If you remember in the original one, it was like more than, I think, 158, I think, megabytes. But here it is small because we run the model only for 2 days. Just here to follow the steps. After running the model, we can open our output result here just to check the time step and to check everything. This is the output file. So this is first here the time. You can see the time step, it is every 15 minutes because we said 900 seconds the time step. So it means it will calculate like everything every 15 minutes. We can change the time step in the master file, but here as you can see, it is 15, 30, 45, and then starting a new hour like that. So it has only, if you look at the date, this is the 1st of April, and we selected, I think, only like 2 days, not more than that. So this is the time step, it is here. And these are like some result related to the discharge and to the precipitation over some specific locations. We are going to come back to these locations. Where are these locations later? Because we are almost finishing now our session because there is another meeting at 10, the federal meeting. So you don't need to miss that important one. But this is like the result of the model. It is available here. We can later, this is just a quick test if the model is running well in your like a PC or laptop. But we are going to also to prepare together and to run the model again with maybe full 2 months or even more. But this is a quick demonstration and to check if the model is running well and where are the output and how to check them. So also this output netcdf file, we mentioned that we can use also Panoplay to open and to check this file. So this is just quickly like how you can run the model. and this is like the file that the Excel file or the Excel format file that you can open and check quickly the result. So this is just briefly the steps for running the WFlow model, and this is like a quick demonstration for running the model. So maybe I will share this recording after the session to test and to check if you want. Yes. Thank you. Thank you very much. If you have maybe any quick question before closing the session to allow you to join the federal meeting. Yes. Yes. Very good. Very good. Very good. I'm going to share immediately the training, but allow me to thank you also for coming on time and for the interest to follow like this training. And this is very important and very much appreciated. Thank you. Thank you. Have a good day. Have a nice weekend. Thank you.